What's up, everybody? Welcome back to yet another episode of Basic Chem 101 with SIHLE BONANI. My name is SIHLE BONANI, and today we are doing the periodic table of the elements. Let's go.
Let's go. This is how every child that wants to make it one day. Zimbo say class and presence of mind is elsewhere. Bring out Uzuzani, Abna, already Alispani, and the timer is nowhere. I know your pain, you don't have to be scared. The dreams are very pure, they are written in focus. Keep that pen and paper, they will take you to that day. In the meantime, stand up.
Today we are meeting in very difficult times for the country as well as the world. So I'm not sure where you will be watching this and what you'll be preparing for, but these are good times for us to catch up before everyone else catches up on us. Remember, I had started with talking about your Lavoisiers and your Daltons. Today we are talking about we're going back to 1869. We're talking about a Russian chemist and a German chemist. They worked independently, but they came to the same conclusion. The Russian chemist was Dmitry Mendeleev, and the German chemist was J. Lothar Meyer. Now, when they worked differently, they worked independently, they put together the elements and they put them in an order of mass numbers or atomic masses in horizontal rows, one row under the other. When they put that in such a manner that the vertical rows in that table that they were putting together, the vertical rows had, the elements in vertical rows had similar properties. So when they did this, they came up with the periodic table, and the periodic table is defined as that tabular arrangements in rows and columns, highlighting regular repetition of properties in a vertical column. That is called your periodic table. But as time went by and further experiments were done, it was found that there is a discrepancy in the arrangement of those elements and the properties that they were looking. So there were changes that were made. Instead of their rows being put in terms of atomic masses, they were put in terms of atomic numbers. And then from there, that is where you find the periodic table as it is today. So those discrepancies that were found when using mass numbers, they disappeared. So that is how you came to your modern version of your periodic table. And you'd also find that, I'm not sure if you see this periodic table, but you will also find out that the vertical rows are given names. Your vertical rows are named as your groups, and your horizontal rows are called your periods. So this is period number 1, which is your hydrogen and your helium. And you have your period number 2, period number 3, period number 4, period number 5, period number 6, period number 7. So from there, you find that that is how you gonna group your periodic table in terms of groups and periods. So we'll try, if you can see that this is what is called, this looks like a staircase. So from your period 1 and your period 2, your group, which is, let's say this is group 1, this is group 2, then you have your groups there. So in this staircase, this group and this group, this is your main group elements, and also this is your main group elements. Down the staircase, you find your transition elements. So that is how we would group your elements. So you keep in mind you have main group elements and you have transition elements. So from there we will go and try to break down what the periodic table is about. Now we had agreed that we'll call these elements as your main group elements, and the ones between we'll call them the transition metals. Now focusing on the main group elements, let's now number these groups as group 1, group 2, group 3, group 4, group 5, group 6, group 7, group 8. So we have 8 groups in the main elements. So in the main group elements, or in the periodic table, on the left of the periodic table you find what is called your metals, and then on your right you find what is called your non-metals. Now your metals, they are known to be shiny and ductile. They can be rolled into sheets, which is they are malleable. Also, your metals are good conductors of electricity. Your non-metals, they are the opposite. Now, mostly your metals are solids in room temperature, and your non-metals are mostly gases. But you'd find that sulfur is a solid. Sulfur and another one. Sulfur is a solid, and also bromine is the only liquid non-metal. For metals, only mercury is a liquid at room temperature. So that is your metals and non-metals. But you find that there is a border between a metal and a non-metal. You get what is called a semi-metal or a metalloid. Not sure about my spelling. Your semi-metal or your metalloid. A semi-metal, it exhibits both your characters of a metal and they are also semiconductors of electricity. Now, semiconductors of electricity, you find that at room temperature, they are poor conductors of electricity. But when temperatures are raised, and you find that at higher temperatures, your semiconductors become good conductors of electricity. And in your periodic table, you find them in also a staircase which act as a barrier between metals and non-metals. So this side you find your non-metals, and also this side you find your metals. So your metals and then your transition. So your transition are all metals, or your transition elements. We can also name them as transition metals. So from there you also find that, I think we have already spoken about this, but your group 1, they have similar, or they have the same properties. So your lithium, your sodium, your potassium, they react vigorously with water. And also your group 1 elements, they are usually called your alkali metals. Your group 2, they are usually called alkali earth metals. Your group 8, they are called your noble gases, and your group 7, they are called halogens. Now, your group 3, 4, 5, 6, usually group 3 is named by the first element in the group, which is your boron. This would be called your boron group, and then this one has carbon. This would be called your carbon group, and this one would be your nitrogen group, oxygen group. But usually the oxygen group are also called chalcogens, which is your group 6, which is your chalcogens. Now that is how we break down your periodic table, and for now, this is where we stop. So moving forward, when we talk of a group, when we talk of a period, you have to know where we are where in the periodic table we are located. So for you to understand a periodic table, you have to understand these fundamentals. Thank you very much for watching. This has been Basic Chemistry 101 with SIHLE BONANI. My name is SIHLE BONANI. Please make sure that you subscribe to the channel so that we can catch up before people are catching up on us and we are swamped up with too much work when you go back. And also leave us a comment below. Like the video if you like it, also dislike it if you don't like it. Tell us where we can improve. What else do you want us to talk about? Thank you very much. See you next time. Booyaka!